So we've been talking about areas a lot. It's time to take the next step, the volumes. Remember, we started out in our geometry talking about a point. And a point is nothing more than that, a location. And we took that point and we moved it in a single direction. And that made a line segment. And if you remember, the length of that line segment just equaled the distance that we moved the point. And that is one of the technical definitions of a length. And then we took that line segment. Now, of course, this was one-dimensional because we had moved one direction in order to create it. Next, we took that line segment and we moved it in a second direction, perpendicular. And we haven't explored, we realized we don't have to actually go perpendicular as long as we measure the distance perpendicular to create an area. And the size of that area is related to what the original length of that line segment times the distance it was moved, which we usually refer to as a width. So area was length times width, or length times the distance. If it wasn't, a width, it was distance from where it started to where it stopped, measured at right angles, perpendiculars. That was two-dimensional because we moved in two directions. Well, now we're going to take that rectangle, and that is a rectangle. Pretend we're sitting on the ground, we're kind of looking at it from up above and at an angle, so it looks kind of oblong, but that is just a rectangle. And we are going to move it in a third direction that is perpendicular to the first two, lifting it up. And if you kind of trace its movement through space, it forms a box. The size of that box versus that box creates a volume. The amount of volume depends on this original area, which we'll call the area of what's called the base, and the distance that it moved, which we refer to as a height. So it's the area of a base times a height. Now some abbreviations. The area of a base is just going to be A with a little b by it, and of course times H. Now many of you have heard boxes defined, volumes defined, length times width times height. Well, what is length times width? The area of the base. So that is just length times width. So for a box, that does work, length times width times height. The reason we define it this way is because we're going to run into other shapes that are not boxes. This formula will still work for it. LWH would not work for it. The base is always that shape. Here it would be this rectangle on the bottom. It's always that shape that we had to grab onto and pull to create that object. It's called a solid when you have a three-dimensional object. So the shape that we had to grab onto and pull to create that solid. For those of you that are having a hard time drawing these boxes in your notes, let me show you a cheat. If you draw a rectangle, now if you're having a hard time drawing a rectangle, well, there's not much I can do for you. I've struggled with it. I struggle with it too. So from each corner, you go up and over. You can make dots like that if you want to. Or you can just draw another rectangle the same size approximately that's offset a little bit. Connect the corners. You have a box. Now on a box, there are 6 sides. Opposite sides match up. Like here, the bottom's going to be the same as the top. The right end's going to be the same as the left end. The front's going to be the same as the back. So there's really only 3 unique sides in our rectangle or in a box. Any one of those three unique sides could be the base. So we're going to choose the base to be the bottom. Let's give you some dimensions here. So let's say this box is 18 by 8 by 10. We're going to start out by finding the area of the base. How do we find the area of the base? 18 inches times 8 inches, otherwise known as 144 inches squared. So then to find our volume, 144 inches squared, area of the base, times that height of 10. The height will always be perpendicular to the base. So 1,440 square inches times inches is cubic inches or inches cubed. Here's our volume. So why did I define volume to be the area of a base times a height rather than just length times width times height? Because I'm going to do happy things to you like this. Come on now. There we go. Now here are two things. One, the base is not the bottom of this. Two, length times width times height would not work here. What is the base here? Got this end, this triangle, because that's the shape that you could drag through to make the object, right? Make the solid. So we're going to start out. I made that a right triangle to make it easier on us. The area of the base is found by doing what? 8 inches times 15 inches divided by 2, 60 square inches. So then my volume will be 60 square inches times 20 is that dimension. Notice not only is that height perpendicular to the base, but there's always two bases on these objects. It's the distance, the length that connects the bases, or the distance between bases. So that'd be times that 20 inches. So that's 1,200 inches cubed. How are we doing so far? Come on. Well, we can also run into shapes like this. Of course, this is a cylinder. Rather than having a separate formula for a cylinder, we can use that same formula. First of all, what is the base here? The circle. We know how to find the area of the circle, so the area of the base is going to be what? Pi times 4 squared. 4 would be the radius, half of that diameter of 8, which is going to be approximately 50.24 feet squared. How do I find my volume? Multiply that by my height of 10. So 502.4 feet cubed. Use the pi key. So you can see that formula, area of a base times a height, applies to pretty much anything. On this shape, what's the base? Not parallelogram, but trapezoid. I want to give you guys a minute to try to find that. Find that volume. Talk about it in about 40. So to find the area of the base here, it is a trapezoid. So we 16 plus 30 over 2 times that height of 12. What's that give us? Is it 276 inches squared? So then our volume is found by taking that 276 square inches times 24 inches. 6624 inches cubed. How many of you had that? A couple? Any questions on how I got it? All of it? Well, do you see why the trapezoid here is the base? Yep. So then the area of a trapezoid is base 1 plus base 2 divided by 2, average of the bases. So those are the bases. The two parallel sides of the trapezoid are the bases. Okay? So if you add those together, that's 46. You divide it by 2, that's 23. Then you multiply that by the height, which is the distance between those two bases, which is the 12. So 23 times 12 is the 276. So then once you have that area, that volume is the area times the distance to the other base, times the height, basically. 24 is the distance to the other base. So you take that area of 276 square inches times 24 inches to get the volume. Well, let's say that this is, the base of this is a rectangle with a half circle on the end of it. Let's say that this here is 8 feet. This is going to be 12 feet. This is going to be 14 feet. I want you to take a couple minutes in your notes, see if you can find the volume of that. And we'll talk about it in just a minute. So the base on this is that bottom piece there in the blue. So to find the area of the base, we've got to do two pieces. The rectangle and the half circle. The rectangle is 8 feet here. What is it here? Well, what's the radius of this circle? What's the diameter of that circle? 8 feet. So the radius is 4. So it has to be 4 this way as well, right? So that makes this 10 feet. So that's 8 foot by 10 foot for that rectangle, which is 80 square feet. Plus we have the half circle, which is pi times 4 squared divided by 2, which is 25.12 square feet. which gives you the area of that base is 105.12 square feet. So then for our volume, is that 105.12 square feet times that height of 12 feet gives you 1,261.44 cubic feet. Is that correct? Okay. How did you break it up? Did you break it up like I did into a rectangle and half circle? So what'd you get for the rectangle? Okay, because you were doing 8 here and by like 14. You forgot to subtract. I think that's usually the mistake that most people make is they forget to subtract off the radius of that circle to get back to the length of the rectangle. That'd put you at like 112 for the area of that rectangle. Okay. Well, then that just means we should try another example or two, right? Let's try another one of these happy problems. So these are right angles here and here. This one obviously is not a right angle. We're going to call, well, let me get the other side drawn, the top drawn first. Okay, so let's say that this side here is 12 feet. This up here, we're going to go at 18 feet. Oh, let's see, we're going to go 30 feet here, 7 feet there. Now the 30 feet goes to here, by the way, to the start of the circle. And we're going to go with a radius here of 2 feet. We're going to call this height 15 feet. So obviously your first step, find the area of a base. There are several ways you can break that up. You'll have to cut that half circle off. From there, there's a variety of things you can do. You can cut it across here to have a rectangle and a trapezoid. Or you can cut it. Now, there's a lot of different ways you can cut it up. I'm going to let you do that. So let's do the area of that base first. Then we'll go from there. So, almost done? You want to wait about it? Okay. No problem. Okay, so for just the area of the base, like I said, that half circle, there's no other way to do it but to cut that half circle. So that's going to be pi times 2 squared over 2, which will be 6.28 square feet. The rest of this, I'm going to cut it the easiest way I know how. It's like that. Piece 2 here is a rectangle that's 4 feet by 30 feet, or 120 square feet. Piece 3 up here is a trapezoid that's 18. This here is going to be 23. And then across here is 12 minus 4, or 8 feet. So that area for piece 3 will be 18 plus 23 over 2 times 8, which is 164 square feet, correct? That all adds up to 290.28 square feet for the area of the base. Eraser going here, area of the base. So then for our volume, it's the 290.28 square feet times the 15 feet of height. What does that end up being? Point what? 2? That's feet cubed. That's our volume. First of all, how many of you got this for the area of the base? Got. Gotcha. Yes, sir. For this? Oh, you didn't realize the 30 went there instead of going all the way to the end? That's understandable. Yep. That should be fine. Yeah, that's fine. What would happen if you rounded different or used the pi key? It'll be a little bit different. What I usually do on my quizzes and tests is I do the answer, I calculate it once using 3.14, and I calculate it again using the pi key, then any answer in between those is accepted. That's your tolerance, yes. What, okay. One of our applications of volume is density. Kind of like we had the pressure we used for area, we can use density with our volume. Technically, the definition of density is mass divided by volume. But that formula, which we abbreviate just D is equal to M over V, that formula can be rearranged in several ways. We can calculate the mass as volume times density. Or we can calculate the volume as mass divided by density. So let's say we have a material. Let's say we have a metal. Whoa, what just happened there? Huh. Let's say we have a metal that we know has a density of 132 pounds per cubic foot. We want to know how much, what volume of metal we have. We can actually just weigh it. Let's say it comes out to be 400 pounds of material sitting there. So our volume would be using this formula is the mass. Now technically 400 pounds is a weight, not a mass. We'll discuss that difference at some point here. Divided by the 132 pounds per cubic feet, which is going to give us, what, 3 point? Sounds about right. 3.03 cubic feet. Now, I want to talk a little bit while we're here. I think, bless you, I think we mentioned it before, something called dimensional analysis. If you haven't noticed yet, I don't memorize a lot of formulas. I mean, I have them memorized, but I don't use them. I always like to go back to basic concepts. When I try to memorize things to do stuff, there's a chance that I remember it wrong and I screw it up. If I understand the basic concept behind it and figure everything out from there, there's a better chance that I'm going to have it right. Because It's a lot easier to remember a few basic concepts than it is to remember the thousands of different formulas that are out there. So in dimensional analysis, rather than trying to remember that volume is, come on now, is mass divided by density, I can use the information I have here where I had, my density of 132 pounds per cubic foot and my total weight of 400 pounds. I know I'm trying to find volume. What units are volume going to be in? Cubic feet, right? Cubic feet or cubic inches. Well, here in this problem, I have cubic feet. So my answer, I want cubic feet, and it has to be on the top of a fraction. It can't be on the bottom of a fraction. So I need to figure out some way that I'm going to have that cubic feet be on top. Well, when I look at this, this is a rate. And that's actually can be thought of as 132 pounds over 1 cubic foot. The only way that cubic feet can be on top is if I divide by that. So we've talked about some of our measurement conversions using that conversion factor. It's exactly the same process. If I want to start out with 400 pounds, I want to have my cubic feet on top. So I got to have pounds on bottom. 132 pounds is 1 cubic foot. That density can also be thought as a conversion factor. 1 cubic foot equals 132 pounds. The pounds cancel each other out, and I'm left with cubic feet. So that's 400 cubic feet over 132. You divide it out to get the 3.03. So here, you don't even have to know the formulas. The units themselves tell you what you have to do with the numbers, what operations you have to do. Now, the problem with it, the difficulty is you have to do, everything has to be multiplication so you can cross cancel. And you're working with fractions a lot. But fractions, if you get used to them, learn to be friends with them, they are an incredibly powerful tool. Careful. I'm actually Belgian, which is close. All those Soviet bloc countries are the same, right? Oh, sure. In your little book, it's going to be Unit 31. I'm going to have you work on that for today.